Alright, so as you know from the last time, we've managed to implement the stack compiler in itself, and something that I've changed was to just rename the extension to stack because SL was taken by slash or something. It's not even a real programming language like stack is, but whatever. And we've also managed to remove all the C code, as you can see from the GitHub statistics from the repo. And yeah, I know it doesn't recognize stack as a language because GitHub sucks, but um, yeah, everything is written in stack. There's only the bootstrap stage where we need assembly, and the reason for that is uh, first you need to somehow build the first compiler because it's like the chicken or the egg problem. We don't have the executable at first. So how do we generate the executable? Well, we have some assembly that gets compiled into the executable, and then we can use that executable to recompile stack.sl, right? So that's the entire process of this thing. So we can check that out in the makefile, right? I've modified it a bit. So initially we just assemble the stack.asm file from bootstrap, right, and link it into an executable, and then we can just run the executable on the stack file, right, do the entire pipeline, generating the assembly, generating the O file, and finally generating the executable again. So it's like a cycle, right? It starts from the executable and it ends with the executable. So that's how we generate the new version of the compiler, right? So if we make any changes, we just run make. It takes a bit of time because of type checking. That's the slow part. I'll have to figure out a way to improve those. Maybe if we have while loops, it's gonna be better, but we'll have to see. Hopefully it's gonna be better, I'm not sure. More efficient, I mean. And something else that I want to add is the match keyword. And if we go ahead and look at some of the examples, I already have one for how I want match to work, but it's not in the language yet, so we have to add it. And my idea of match is something that generates some constants for you. So for instance, here it's OK and axis. And instead of you having to use dupe, swap, and so on, you just use a match, and it matches the last, for instance, here it's only 2 items, so it's gonna match the last 2 items of the stack. So here is a boolean and an array, right? And then on the stack, it's left the rest, right? The integer and the string. So that's kind of my idea on how match is supposed to work, right? So yeah, and yeah, we'll have to see how we are gonna implement these two guys, the OK and axis, because yeah, I mean, I don't know. It could be that we implement them with the pick function. So for instance, axis could be, let's say, axis could be pick the first item of the stack, right? But it's also gonna need array dot star, right? We need to dereference it because pick returns a pointer. So I think this is how we are gonna replace these things in the code when we use a match statement. So maybe the match statement is gonna be just a preprocessor thing, but I don't know, maybe it could be, right? It could be just a helper, and it just converts everything into things like this. So yeah, we'll have to see. But I mean, it also needs the types, so it cannot really be a preprocessor, right? So it should be something that yeah, but we'll have to see, right? So that would be the plan. And yeah, it takes a bit of time. I'm not sure how long it takes though to recompile. I think it's like 3 or 4 seconds. but it also takes up a lot of memory, right? So that's another issue we have to solve. But as I said, I'd like to start with the match keyword, add the AST, do some type checking, and we'll have to see how things process from there. But yeah. So if we go to the stack file, we can just start to add things to the stack.stack file. Now it's called stack.stack. Yeah. Stack token match. So we already have, so it's a match. We already have the in and the end keywords, so I wouldn't need to add them, but we need to add a match. So yeah, that's that, and then let's just duplicate this line and add match as a case here, and also remove all the, like, put another if and here. Yeah, I mean, probably adding else if would be a good idea, but kind of like this this thing. Anyway, so now that we added the token, right, we need to go into all the places where we have these kinds of ifs and generate the match. So for instance here, this is parsing a name, and funnily enough, the match keyword is a name, so we can just copy paste this thing, right, and say here match. If we find a match word, then we just use the match token, right? So that's the first thing. And I think the lexer should be done. I think that's all we need for the lexer. Just find the keyword called match and the token for it. I think that's enough for the lexer. So if we just run make, yeah, what? Did I forget anything? I don't think so. Oh, did I mean, I added a fee here, right? Maybe I forgot about it. Oh yeah, and the to-dos and the, like, the file and line macros are still bugged. I know it sucks. I have to figure out a better way of doing it, because currently, like, almost all the things in stack are gonna be references, so you are gonna have a reference multiple times to that constant, so it sucks, right? And yeah. Okay, so if we check the tokens, we should see probably a match. Yeah, right, we see a match. And yeah, like, the problem right now with the in stdlib with file is that it gets expanded here, and it gets expanded with this line and this file name. So I have to figure out a way of actually setting the right file and the right you know, line number and so on. Yeah, but anyways, let's go to the parser. So right now the parser only knows how to parse the, like, expressions like if plus, but those are just the function names, right? So pretty easy expressions, right? Conditions, names, strings, numbers, and booleans. And we would have to add the match as a stack AST expression. So I would say const stack AST match, or I guess expression match 5. And we can add here stack AST match, and this one I think it's gonna have a node for the match. Like for the match word itself, right? It's gonna be a node, and then we are gonna have an array of bindings, we could call them binds, and these are gonna be nodes as well, right? They should be nodes. And finally, it should have a body of expressions, so array expressions. So here I guess the first array is array of stack AST node, and the second array is an array of stack AST expression. And if you compare that to the if statement has both of them are arrays of expressions. So that's how I think the stack AST match should look like. It should have a list of the bindings as nodes and a list of expressions. Okay. Right. So next would be adding them as, so we add them as expressions, right? And we just have to parse them once we get into an expression. So let's try to find where we do condition, for instance, and just add the match there. So for example, this is the printing, which I mean it's would make sense, I guess, to print the match, like implement the dump first. I guess why not, because we are gonna need to implement the dump anyways. So else loop stack AST expression match. So if we find a match, we would have to, so what do we have here? Yeah, so we have probably the same logic, but here is going to be a match AST, right? Then we probably need to do the same stuff right here, and we get another match, and then we probably have dump match, right? Dump match. And I'd say we can just copy paste this thing, right? Dump condition is gonna look really similar. So dump match, we are gonna print a match like this, right? Then I guess we need to print all the names. So here it's like a to do though. Let me just say that this is a match, and here it's a match as well. So we have matches. Question is, okay, maybe I can do it like this. match indent. So we print the match keyword, then we should maybe, I'm not sure how I want to print it. Do I want to print the bindings on the same line or as a separate line? Maybe they should be on the same line, like this. And then here it's gonna be like a to-do. Right, what do we need to do? And then here we have again like the in and end, but I'm not gonna print the in and the end. We are just gonna print the expressions like this. And here it's stack.st dump indent plus. Yeah, it's the indent. Okay, so this is match. Then here we have the match AST with its expressions. Right, so we have the expressions, and we just call to dump expressions to print those expressions. And again, I wouldn't really print anything at the end, maybe just a new line, right? And we have like match and indent, but we need now to print all the names. And pretty sure a easy way to do that would be like dump arguments, because arguments is exactly what we need. So dump arguments, if you think about it, is exactly what we need. So I'm gonna call it dump binds, right? And this function is gonna take as an argument, I guess it's an integer for some reason, I don't remember why. Oh, the indent, yeah. So it takes in the indent, but we don't even need the indent. So I'm just gonna say it's gonna be the I and the names, right? So it's just gonna be the I and the names of the bindings, right? And this is gonna be an array of nodes. Okay, so here we are gonna do dump binds, and here we can just dup2, remove the indent because we are not gonna use that. We get from the array, right? That's cool. And here we are not gonna do this rot4 because we don't care about the indent. It's not used. So what do we want here is to just generate the node value and print like let me just do it in the reverse order. Print a space and then the node value. That's what we want to print actually. And in here we are gonna have basically I and names left. So then we have to swap and swap back. So the idea is we have the node, we print a space before it because we have to put like space name, and so on, right? And here it's only pop2. And then we take the string from the node and print the string from the node, right? That's the idea with the binds. All right, so here what we have to do is to probably do a swap dup stack.st match expressions, or I guess binds, to get the array of nodes, right? Then we can stack st dump binds, so we also consume the array, then we swap back and we get match and indent. And I guess you can see how beneficial it would be to have a match keyword, because we would get rid of all of these swaps and dupes. Would be less like mental overhead keeping track of them, and we can just get rid of these comments. Basically, that's how useful a match keyword would be, right? But anyways, we get that, and let's also print a new line afterwards, because yeah. So that's how I see this this thing being printed. All right, we could try to out SLC stack. Let's try to type check it, because if we have any errors, at least we run type checking on the thing, right? I mean, I'm not sure how I can visualize how much memory this thing takes up in real time. That would be interesting to see, but obviously it consumes a lot of memory because we don't free anything. Like everything is allocated on the heap, and it keeps getting allocated. So yeah, that's the reason. So maybe we'll have some kind of, not necessarily garbage collection, because I feel like that's, you know, not the right approach, because we should be able to know when a variable gets like should be freed, right? Like it should be obvious when that happens. Okay, because you know, if it's gone from the stack, then it should be freed. So that's the way of freeing things. Yeah, I mean, I'm not sure. Maybe it's garbage collection, but we'll see. So here is the dump expressions. We just added the match. That's good. But we also need to go ahead. This is stack preprocess. So where is the parsing though? Maybe I went past that. Yeah, I think so. I think I moved past it. Okay. So when we parse an expression, right, we are looking for these tokens: a name, a number, a boolean, a string, a token if, and lastly we look for the match keyword. So let's not forget about a fee here, because we added an extra one, and this one should be token match, right? And if we find the token match, we want to parse a match, obviously. And here we have stack expression match, right? We reference the match and we generate an expression. Nice. But now we need this function, right? We need to define this parse match. So let's just copy again the condition, parsing, rename this thing into match, and we should return a match. Right, first we should read a token, that's for sure. Then what do we do here? We take parser and node. Interesting. Stack token L, stack token fee. I mean, this one Doesn't really make sense, but yeah, whatever. So what we have to do is to read, but we don't want to parse expressions. We want to just read nodes. So maybe we can find something useful in function parsing. So let's see if we can find stack parser parse func. So in parsing a function, we check that we have a func keyword, then a token name, then whatever L parenthesis, and then we parse names until. So this one looks kind of useful because it parses stack AST nodes. So I'm gonna copy that. All right. So we have a name and parser. So this node is just the name. So if we vsplit, let me just, if we search for data stack AST match, you can see that we have, we have a node just to keep track of where the match starts, and then we have the list. So this is the match node, right? So we can just kind of swap it. So we have the match and the parser. Here we are gonna duplicate the parser. We are gonna put an array that's empty. I mean, I should probably do this. So we have the match keyword, and then parser, and an array of nodes. That's empty right now, but we are gonna do something with it. And we are gonna run parse names until. Right, and parse names until takes the parser, an array, and returns an array back. So it's yeah, you know, just it just gives us the array back. So that's what we get here, the match node, array of the names. And if you remember from data stack AST match, we have almost half, more than half of the structure, because we have the node, we have the array of bindings, and we just need the array of expressions. So next step is to, I guess, stack parser function is really useful here, because parse func, because we are just gonna look for the in token, then parse expressions, and then initialize the thing. So if you think about it, that's kind of it, right? So we are gonna force parse an in token, right? We are gonna force parse this in token, and here we are gonna be left with a match and array of nodes, and then the parser, right? We duplicated the parser, then we read a token, we took its kind and checked that it's an int token. Then we duplicate the parser again, we put the end keyword, expression, initialize the array with expressions, it's empty array, and then parse until we find the end token, parse expression until we find end token. Okay, and then we swap pop. So what that means is we are gonna be left with, and here is gonna be just the binds, right? So we're gonna be left with the match node, the binds, and the expressions. So we can just easily match init, and we have a match, right? So that's how I think this thing should work. Let's just make sure that it successfully type checks, and then we can run it on the example file, right? And also, speaking about examples and tests, I also want to add more tests. Maybe I'm gonna use ChatGPT to generate some tests. because right now we don't have that many. Like if you look at it, we have a few lexer tests, a few parser tests, really few type check tests, but would be nice to have a lot more. But yeah, so it successfully type checks. That's pretty nice. Let's run make. So make should in fact run the compiler like the old compiler on the new code. So it should generate assembly for this code in particular. Then it should compile the assembly into an executable that should be capable of parsing matches. So we'll see if that's true. So now if we run this thing on the match, the lexer still works, obviously. But how about the parser? How about... So that's what I'm not sure. Do I have to run make twice? That's a good point. Because we got a panic. But problem is 3312. Problem is that yeah, like the problem is that my panic doesn't really work. Parse dot match. So yeah, that's something else I have to fix, and it's extremely painful. But yeah, well, I'm not sure why it panics. Because I literally parse that thing properly. I don't see an issue. So no, like it's weird. I think I forgot something here in parse names until. Looks pretty scuffed. Oh, parse names until. I think parse names until. Oh, it's hard coded like this. Shit. Okay, it's hard coded like that. So let's go in parse match and parse names until 1. We can just rename this function. So if we find a name, then we whatever, then if we find a parenthesis, then it's fine, otherwise it's not. But here it's not parentheses, it's token in. Also the problem is that I don't want to read the token. Until in. Right. Don't really want to read the so if we find the token in, otherwise we do that. It shouldn't really be possible to have a match with nothing because it doesn't make sense, so I'm gonna ignore that case, right? So we are just gonna have all of this in the main function. But I can see that I'm doing a swap. Okay, it doesn't matter. So I'm gonna do it like this, parse until in or something. Parse until in. So basically here we swap we dupe the parser, we read, we expect a name, right? That makes sense. We take its string, its position, and whatever, we create a node. That's good. And then we append that to the array. Makes sense so far. After that, we should probably just pick. And if we find an int token, so if we pick and we find an int token, that's like, okay, we should stop because we found the int token. But if we don't find the int token, then we need to go again, start from here until we find the int token. Now this can be a bit of a problem if, for example, okay, so this one is extremely weird. So I pick, I dupe, but I should maybe just, well, I should maybe just do this instead. And here say that we have an array, parser, and kind. Right, and here we have kind. So it's gonna be much easier. So if we find a token in, that's good, we stop. But if, for example, we find stack token and the file, then array parser kind, this is an issue. So we do like a to do pop2, right? That sounds like a problem. So if we just go ahead, here it should be until in. And the other function was, I'm curious about, okay, error handling is just pop that. Okay, so here it's like, if we find the int token, when we pick, we just return. If we find end of file, it's an error, and anything else, we go again. And if it's like anything else but a token name, it's gonna be an unwrap error here. Okay, so I guess I'm happy with that. So let's just type check this. Oh, I forgot an if probably. Oh yeah, and the parser is just bad. If you do like syntax errors, you're cooked. But I'd say the language is so simple you cannot make syntax errors. Or if you make them, it's like easily, you find them easily. Like here, for instance, it's like, oops, I forgot to. Right, so the point would be to run the compiler as often as you can, in my opinion. So if you do that, you are probably safe. Okay, so now if we try to run this thing on the match, we actually see the match, right? Okay, axis, and then the body of things. And as I said, now it's a bit interesting. Should we make the match? Like, that's my my question right now. Should we make the match collapse during like during the preprocessor stage, or should we keep it until later on? like the idea would be to generate the constants, the axis and OK constants based on the returns, or I guess on the arguments, right? But that's not necessarily true though, right? Because the offset is gonna change, so that's not gonna work. So we have to do that during the assembly somehow. We'll need to do that, and I mean type checking as well needs to work. So it's gonna be interesting. I have to, like, maybe we'll finish the type checking today, like, hopefully, but I have to figure out a good way of generating the assembly properly, because yeah, it's right, we cannot use the offset properly because the stack gets shifted, right? And I also said that the match is gonna clear the stack, right? So it's gonna remove OK and axis from the stack. So that's also another thing that we have to think about. So yeah, okay, let's then go to type check. Oh, stack. Let me just add this one because this is the only file left. So if we go to main, I'm curious, does the preprocessor run? I mean, it looks like it does. But if we try to run type check, it's gonna complain that, okay, you have to do. So, but again, like the to do is bugged and it's annoying me. I have to fix that as well because yeah, it's really annoying. And as I said, the problem is that if we check the expand, I guess it's expand update, right? What I do here is take all the nodes from the constant body and I'm just setting their position and parser. But the problem is that the nodes from the constant body point to the same location in memory, so I have to clone them somehow. But I couldn't get that to work. Right. And that's really annoying. Where is that? It's in the same place. So for instance, here. Alright. And I was thinking that maybe with the match keyword I can try again to implement update. Maybe. But yeah, we'll see. So let's go to type check. So we have type check function, right? And then we have type check function prime, which is gonna actually run type check function double prime. That's interesting. it should at some point be something like type check expressions, right? Type check expressions. Here is gonna do type check expressions prime, then type check expression, like only one expression. And yeah, I guess here it's the place where we need to do some stuff. So in case we find a match expression, right, we do the expression, we take the match as a match, and then we should run type check expression match. Type check expression match. That's interesting. So maybe it's gonna be similar to the expression condition, but we have to think about it a bit. So what will be another good point here? Huh. I was curious if there is something like, oh yeah, it's this part with infer that I like here. You can see we compare the number of, we should compare, right, the size of the stack with the size of the match bindings, because if we have more bindings than the stack has items, then it's obviously not gonna work, right? So we should do something like this, right? We should have something like this. And it's gonna be something like it needs this return type though. It needs this return type. So it needs basically, so I think this array is the stack, right? Yeah. And here it's gonna be a match. Okay. So context stack and match. All right. So I guess first things is doing a dup2, then stack st match dot binds. So we should get context stack match stack binds. Then we can generate the array count for the binds and the stack. And I guess that if the stack is smaller, so we have context stack match. If the stack is too small, we should have an error here. So let's just put a to do for now. Alright, I'm not sure what the error should be like. Maybe just printing expected bindings, but got stack, right? And there's gonna be something like match has match has not enough inputs or something. Yeah, or match has too many bindings. Match statement try to bind too many items. expected this, but good. Yeah, let's do that. So it's gonna be like this. Like this. And what they say? So we have the thing, type check, match, show f, context stack st match, array and array. I don't match. I don't think we need the extra array. So it should be something like, I should have written that down because I already forgot. Match tried to bind too many items, expected this. I could whatever. I should have like multiple array string show f. That's a good one. I should try to find this function. Right, it's a really good one. It prints an array of strings with commas in between, so it's like pretty good. So we are gonna need this function, right? So we need the following stuff here. Let's actually swap this thing. So we have stack match and the context and the stack and the match. So I could put them like this actually, and we are gonna do something like, I mean, doesn't even help, to be honest. It's better like this because I'm just gonna do a rot prime, and we are gonna have a stack context a match, then we are gonna do a dup2. So we have context match. Maybe I'm gonna do also stack st match dot node. It's the match node. Then the string. So now we have basically ctx name string, and we can call to context show. So this is gonna print stack context match. This thing is gonna print this statement as an error on the proper line and column. So match try to bind too many items, expected, and now I can, for instance, array string show, right? So I'm probably gonna do something like stack st match dot binds. The thing is that binds is binds is kind of like it's like nodes, not strings. So I have to convert them to strings. It's a good point. I don't think I have that function. All right, that would be useful. And another thing I was thinking about, I'm not sure, but yeah, let's try to convert this list into a list of strings. So it's going to be function stack dot nodes node to string. Oh, oh, that's interesting. I already have that function. Nice. But it's called weirdly stack params. But see, it's used for the arguments. Nice. So we already have the function. Perfect. Oops. So basically here we have stack, context, and binds. Right, we kind of lost the match, but we don't care. Then it's stack, context, like array string, right? It's an array of strings. So we can just easily zero swap array string show. So this thing is gonna leave us with stack and context. Then we can say closing parentheses, but got opening parentheses, and then we have to do like swap zero swap array string show. So at this point we only have the context left, and we can close the parentheses with a new line. Oh, and we have to print that to std error. Nice. So here it's like stack context. Okay, so this should be the error message if you have too many items in the match, right? So what should we do then is probably just call the function, right? So it's context match stack, context match stack. So I have to swap and call this function. And it should return nothing. So here let's do a to do pop3. So that's the ideal case when it works. It's a work in progress. But yeah, it's gonna be interesting. We have to define kind of like we had in inference, we have to define like a mapping between like of the defined names somehow, right? Of the defined names, and we need to keep track of them during type checking. I'm not sure how that's gonna work during the compiler stage, because it would be nice to know that at the compiler stage as well. But okay, so it's gonna panic probably here with a to do, right? Again, problem is that ABC. So now it should fail and say that expected match try to bind to many items. Okay, X is ABC, but got int string bool array. So that seems to work. What if we give it 4 things? it's fine. Okay, so this thing seems to work as expected. What do we have to do on the else case though? Well, as I said, we need a list. Well, we already have the list, right? It's inside of match. But that's the part that sucks, right? Oh, shit. I mean, we need to add all of the, so thing is that inside of the match we have expressions, right? So what we have to do at this stage is to go ahead and type check expressions. So we just copy this function, right? And in here, inside of the match, since we have expressions, we just have to type check expressions. Let's take a look at what this function gets as an argument. It takes the context, the stack, and the expressions. So let's try to match that, right? So we have the context, we have the stack, we just need to convert match into expressions. So we can easily do that by doing stack ast match expressions, right? So this gives us the expected result, and expressions returns nothing, so it's perfect, right? It works as we expect. Now if we compile this thing, let's see what happens, because it's going to be interesting, right? What happens? I mean, it's killing the vibe that it takes like 10 minutes to compile. It's still faster than Rust, honestly. It's still faster than Rust, and that says something. Like, I guess the more complicated type checking gets, the slower the compiler. Probably that's... But I mean, the reason why this compiler is slow is because it's bad. But yeah, let's run type checking, right? Well, first of all, we see that we didn't remove the bindings from the stack because it fails, like the stack looks the same. Then function axis is not defined. That's another thing we need to add. Function OK is not defined. So we somehow need to pass the bindings of the match into the context of the type checker, but then we also need to remove them from the context of the type checker. Right, once we are done with type checking the expressions. So that's gonna be what I call pretty scuffed. That's gonna be pretty hard because we have this list. So yeah, if we check the data stack context, you can see we have an array of symbols, right? And these symbols are data or functions. Are data or functions. And I mean the OK and the other like the things are functions, right? They are not something else. We can just say that they are names. But the problem is that if we add them, it's going to be hard to search for them. It's not going to be hard to search for them like hard in like a problem. It's going to be hard because it's going to take some time, some extra time, probably some extra memory, and like it's already looking bad with the how much stuff it consumes, but I wouldn't say it's gonna be really bad. Right, so right. So those should be defined as functions. Do I have an easy way of inserting into the context? I don't think so. Like, how do I insert? Yeah, I don't. I just reappend. Okay. I meant I just reappend into the symbols, right? I guess. Then like this function took me a while. I honestly I used ChatGPT, like I implemented one of them and then I said, okay, do the same but replace the name with that, and these are the arguments, and it funny like somehow it was able to do that. It's pretty interesting. Okay, so we have the append function. Okay, that's good. I guess something else we can do is to have another array of symbols that are gonna be for bindings, right? And when we search here, we do it like, okay, we didn't find it in the main symbols, do we find it in the bindings? But to be honest, no, I feel like if you think about it, the way we remove the symbols should be just popping from the back, because we cannot add, like we don't have functions in functions, so we cannot define new symbols, right, when we type check expressions. And the symbols that we can define are gonna be from other match statements, and the match statements should free their own symbols. So if you think about it, that's how we are supposed to do it. We are supposed to, here, let's just say remove items from stack and add them as, funny how as symbols in CTX. Then pop symbols from CTX, right? So that's how we are supposed to do it. So I guess what I'm gonna do is create a function, stack context type check match. This is gonna be like match init, I don't know, match init, and it's gonna take a context, so stack context, it's gonna take the stack, which is an array, and an array of bindings, which I guess are nodes, but doesn't matter, right? And then we have in ctx, also take stack and binds. And honestly, I'm also gonna put the index here, and let's just use pick, right? So here it's the best case for using a match. It's gonna be I, ctx, stack, and binds, right? But we don't have it yet, so we have to do with the cousin from Alabama. So and that's the pick function. So first step is to generate the, I guess, is to do the check if I is greater than binds. So what I'm gonna do is, so how pick works is you have to count from the end. So 0, 1, 2, 3, 3 pick, int star. It's gonna give us I, and I also recommend if you use pick, you comment each step because it's it would be really painful if you make a mistake here, because type checker doesn't really help you, right? Because you take a pointer, then you dereference it, so it's no type checking at all. All right, anyway, array.count, we check if this thing is smaller than we can do stuff. If it's not, then we end it and we are good, so we can just pop, 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 pop. So in this case we are Gucci. Otherwise, this is ictx stack binds. The next step is to basically pop one item from the stack, right? And this should give us the type of our symbol. Then we should take one item, but from the end of the bindings, so the last item, basically. So we pop again. Wait, we pop again, yeah. So we pop another item from the bindings. So wait a second, we don't even need I then, because I is always gonna be 0 if we just pop. That's kind of true. The only problem is, what if I modify the array and we lose the binding? So let's not pop from bindings. Let's just take the L minus I index. So then what I'm gonna do is 0 pick array star ictx stack binds. We are gonna do array.count again, binds and length. We are gonna pick I, so it's fourth, pick int star stack binds L and I. We should do minus, and we should also subtract 1, because if you think about it, if the length is 4 and the index is 0, you want the third item. It's like the same thing we do with pick. So we are gonna have ictx stack binds L minus I minus 1. All right, so the next step is to maybe do like one pick array pointer swap. I mean, I know I said that, let's stick to the plan, because if we make a mistake here, we are cooked. So we can array get, unwrap, and we know that binds has stack ast nodes, so we can just get the item and dereference it. Context stack binds, and this is a bind, which is just a node. So another thing we have to do is to check if it's redefined. How do we do that? It's like stack symbol get symbol. Yeah. So get symbol. It's gonna be something like this. So it takes a context and a string. So it looks like we need to keep the bind because we need its name. As I said, we need its name because the symbol, we need to generate a symbol. So let's do something like pick 3 to get the context. 3 pick stack context pointer, or I guess the reference. ICTX stack binds bind CTX. So it was 0, 1, 2, 3. Yeah. Then we need the bind. So I'm gonna do probably one pick stack AST node dereference. CTX bind. And we can do stack AST node.value. Right, and after that we can do stack context get symbol. Sadly I put them the wrong order, but now it's too late. So if we find it, then it's not good, right? If we find it, then it's not good. It means that, so here we have, but let's write the types first. Binds, bind, and the PTR. So if we find it, then it's not good because it means that we redefine a symbol which already exists. And I know we could do shadowing, but I don't care, to be honest. Like, just use a different name. You can just, like, literally you can use any symbols, just use another name. Simple. Okay, so now that we know this language is gonna be, you know, a specific political part, just call it that, and we just have to show an error. So it is what it is. I mean, I'm just lazy and don't want to implement shadowing. What I should do instead, if you want shadowing, is to search the symbol from the end, right? So we search the symbol from the end, and if we do that, then shadowing would be extremely easy to implement. But since we already started like this, I don't really want to change it because, I mean, you see the code, it looks like shit, and yeah, it would be really insane to do that. So I have to show the error, something like this, something like this. So it's gonna be, I'm lost. Okay, here. So let's see what we can do. First of all, let's pop that pointer because we don't need it. Stack binds bind. So we have the bind. We can generate CTX stack binds name, right? We generate a name. Then we have a function, or I guess a bind. Bind is, oops, already defined, right? And at this point we should have on the stack ICTX binds and the string, right? Pretty sure about that. So can we swap rot pop so we have only CTX and this? Oh, but you know what? We need to keep the bind. We need to keep the bind because it's a node and we want to show an error. So here is going to be bind. All right. So then here we need to rot for pop. So we have bind, and then we can just use this function context show context name string. Okay, perfect. Context bind string. This is just gonna return nothing. So we know that on this, if we need to return nothing, we need to return nothing. So that's how it should work in case we define the thing, right? So let me just put here like sudo std out poop. Let's poop the thing. Okay, perfect. But I think I need to poop one more time actually. So actually it's like holy shit, it's 1 2 3 4 5 6. Let's just run make. Hopefully we don't have any errors. So yeah, the idea is we'll see if we hit this to do when we run the thing. So wait a second. I do call this one, right? I don't call it. Holy shit, I forgot to call it. Anyways, so here, if we call this function, you see we have context stack binds. Context stack binds. Wait, why did I lost the binds? Oh, they are in the... Wait, what the fuck? Where are my matches? That's so weird. Okay, I lost them. So let's dupe. Alright, so we get the match. And actually, this function takes iContext stack binds. iContext stack and binds. So I'm gonna do here binds. So this is gonna give us binds. Let's do a swap rot for prime. So we get match context stack binds. We are gonna do a dup 3 0 rot for prime. So we get everything else, and then you know, I context stack binds. Then we call to this init, and we have match context stack binds, and that's that. Now we no longer need the binds. We no longer need the binds. So I could push them back, right? And type check expression is, if we go to its definition, it's context stack expressions. So yeah, I think I'm just gonna push the binds back with rot for prime. I'm gonna bring the matches forward. Let's just write this down. Stack and match. Or I guess we could just pop the binds because it's like whatever. So we have match context stack. We could rot dup stack st match dot experts. So we have context stack match expers swap root for prime. Right, so we have match context stack expers. Then we can, for instance, dup3 again, context stack expers. We have the right arguments, right? Context stack expressions. So after this thing, we are gonna have match context stack expers, and now we should pop symbols from context, but for now let's just ignore that. Let's just ignore that issue and let's remake. So yeah, basically we're gonna ignore that, but we need to pop the symbols from the context, right? And honestly, I don't think I care about the stack. Like, the stack can become anything it wants after the match is over, so it should be good. What the fuck? So line 2943, it says that it expected context node string, but it got array node string. The fuck do you mean? The first place where I didn't use pick and it failed. Okay, so we have I context stack binds bind ctx bind pointer. We pop the pointer, so we have only these things left. So we have these things left. We dupe the bind. Okay, we dupe it, and we take the value. Then we put this string, we swap concat, so we have bind name is already defined, so bind name. All right, so we have I context binds bind and the string. So I said that we bring binds forward, we pop it, and then we have I context bind s, so we bring, okay, what the fuck? Best way to see the stack is to do something like if pop 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 pop. Like, this is the, I need a function that does that, that crashes and shows the, okay, what the fuck, and shows the stack. That would be really cool. And it's like a extremely good debugging tool, but we have to get there. We're pretty close to finishing the type checker for this match thing, so that's at least good. And I have to think more about the assembly part. Okay, so we have int stack context, and here we have int context, right? Int context array 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 node string. Oh, I forgot about the stack here. Fuck. Okay, so then we wrote this thing forward, we pop it, we wrote again and pop it to pop the stack, and then I. Perfect. So that should give us context bind s. Context bind s. In case we have errors. But it's weird, why? Why do we have errors though? Oh, I mean, it was type checking, okay. That's okay so far. Yo, it compiled. So we hit the to do, which is pretty good. If I make a function okay in end, it should hit the error. Shit. Why doesn't it hit the error? Because we don't add. Well, that's not true. We have the okay function here, so why doesn't it hit the error? That's really weird. Excuse me, what? 3405. I mean, yeah, because it's the wrong place, but okay, what the fuck? Oh, it starts from the back. So I have to check with axis first. So now it should hit the axis is already defined, right? So that's what you are gonna see if you do that. So you have to use unique names with the global context, let's say. I mean, I'm not sure, maybe we'll do in the future to be able to do whatever, but for now it is what it is. So what do we have to do here is match init. We have to take this binding, right? We need to pop an item from the stack. So if we check stdlib, we have array pop just deletes. We can do array last, array pop. So we have to take the last item from the stack. So let me just, well, let's convert bind into a value first. So it's going to be stack st node dot value. So we have, oh, I forgot, we have to pop because it's a null string, ctx stack binds, and this is the name of the binding. Right, now let's take to pick array pointer, array dot last, array last, we unwrap, we string the reference, so we have I context stack binds name, and this is the type. Right, that's the type. Data stack is not symbol. Symbol function. Func symbol. Context function. Okay. So we have this data type for our thingy. So the name is gonna be name. Input types is gonna be empty, and the output types is gonna be type. So let's do something like that. Let's do string.sizeof array.init with sz, and we should do that twice, once for each thing. So we can imagine that we have more stuff, name, type, args, rets. So I'm just gonna rot, then string.ref array.append unwrap. So we are left with name, args, rets, and we can say stack context func init. So we are gonna have I context stack binds and function symbol, right? It's gonna be the function symbol. func append context func append function. Okay, so this is the next function we need to call. It needs a context and the function. So I'm probably just gonna do something like, so here we took the last item from the stack. That's good. Anyway, I said that I have to do that comment because otherwise it's gonna be bad. Stack context, stack minus stack. Right. So we have to call this function, and I'm gonna do that by doing 0, 1, 2, 3. 3 pick stack st stack context dereference stx, then we can swap and stack context append function icth stack binds. I would also one pick array pointer stack, so we can run array.pop and unwrap stack binds. And why that? Because we need to pop the last item, because we consumed that item into a symbol. Anyway, so that's how we do it here. And now we have to increment I by 1, and we need this thing. We need to call this function recursively. So it's gonna be rot4 1 plus rot4 prime. So we have I plus 1 context stack and binds. So we can just call this function, which doesn't return anything, and that looks good to me. So that's how we are gonna add this into the context. Right now it doesn't matter that we don't do this part, because we don't use OK afterwards. So you'll see what happens if we use OK afterwards, if this thing works right now. So yeah, is it gonna work? It's a good question. Oh shit. So 2950. The fuck? But got array pointer string. What the fuck is that? So here we have type, which is like this thing. So we initialized one array, another array. We just rotated the string, appended that string. Okay, like what the fuck? You know the drill. We use an if to see the stack. I mean, we don't even need to use that many pops. Just one pop is enough. So I'm expecting to see string array. What the fuck is that? Stack function init. Stack data, oh my fucking god, stack context function is like string array, what the fuck? So we have int stack, okay dude, what the fuck? Oh, I lost the array when I did append. Shit. So I need to dupe the last array and then rot 4. Okay. Yeah, makes sense. So like type checking is pretty useful, I'd say. But yeah, what would be extremely useful is that function that prints the stack. I think that would be even better. Like kind of a debugger if we can have that. Yo, it compiled. So if we run it on this thing, okay, it failed in 08 match, so it failed on line 15. I mean, I'm not sure if typing is good for this function, so can do that. Put axis, we swap, we array append, that looks decent. Array get, we have to unwrap, but that wasn't the error. It says that array get has non-matching arms, so maybe we have to unwrap here as well. I think, oh, unwrap is not defined. Unwrap, fuck. Oh, that's a good point. That's a good point indeed. So the reason why that happens is if we go to the preprocessor, okay, let me just preprocessor. We forgot something in the preprocessor. So when we do, Jesus fucking Christ. Oh my, it's gonna suck so bad. So for instance, here when we expand update, we forgot to add the match expression. So how do we do that for a match? But it's weird that it didn't fail here because it's a to-do. Anyway, that's not important. So if we have a match, we have here a match, right? And let's do a dup 2. Let's take the expressions whatever, we run update, right? And then we are left with what exactly? With that, so this should be doing that for the expressions, but we should also, so yeah, update it fucking sucks, but it is what it is. I really don't like the current approach to the macros, but it is what it is. Yeah, maybe we can do better once we have more features, but for now it's really bad. It's really annoying. But I mean, the fact that we have to update the preprocessor each time we add a new a new expression, it's not that big of a deal, in my opinion. I think it makes sense that this is something you have to do, right? Like it makes sense. Because you just added a new like thing. You have to change it almost everywhere in a compiler. You cannot really. Okay. So now we should expand macros in matches as well. I think that was the missing piece. Should be able to expand macros. Oh shit. Ah, 939. I made a typo. This should be match. This should be a match, not a condition. But this was for update, so it means I made an oopsie doopsie in expand as well. Match. Okay, just stop. All right, so that should be good. I hope. Okay, so that's what I think. Okay, I mean it looks good that we don't have any errors so far, and the memory is at 95%. Like that looks good. It's always a good sign. Shit. Okay, the fuck? So we literally went ahead and put our case here in update, also put it in expand expressions. Oh my god, I forgot. It should be match. Did I make the same mistake here? No. Okay, I think that was the bug, using the wrong name, but yeah, the rest of them are fine, I think, hopefully. Feature function, expand special args. Okay, so expand special args needs this as well. That's crazy. I need to find a better way of doing the special like the line and number, because they suck. First of all, let's so here we have expressions. Fuck. Match. Okay, so that should fix the. This should fix the special case with special args that probably don't expand on that. And do I have anything else? I don't think so. Like offsets and yeah. Jesus Christ. Like, I'm pretty sure it would have been easier if I just wrote these things as strings and then somehow executed the lexer on that string instead of writing them manually. I am pretty sure that would have been easier. Okay, so if we run the type check now, it works. Nice. And as I said, if we go to 08 and Okay, what does okay do? Okay is a boolean. So if we do okay if v like doesn't do anything, it's not gonna complain that okay doesn't exist, right? But it should, because look, if I put this thing here, it's gonna complain, right? So how do we get that? Well, we have to pop the symbols from the context. So the same way we did this function, we have to do the reverse. We actually have to do the reverse, but it's not gonna be that complicated. We are gonna have only the we are only gonna have the I context and binds. All right, I mean, let's just use pick for this one as well. Why not? Why the freak not? So if we have this thing is less than, it means we can pop from the context. So I can do something like swap. I mean, come on, this should be like what? No, this is what it is. Let's use pick because I'm too lazy to think. So let's just do one pick stack context dereference, my context binds context. I'm then gonna do stack context dot stack data context. It has symbols, right? So we have to we have to take the symbols. So we have I context binds symbols and just do array pop unwrap, and we have I context binds, and let's just do rot 1 plus rot prime, and let's say match clear. So this clears the context, right? That's not written anything. So, and again, this only works because we don't, like here we add symbols, right? And here we remove the symbols. So it's not like in between we are gonna do something else with those symbols. That's what I believe. Yeah. So I context binds, I context and binds. So let's just do something similar to the first one. I'm gonna swap. So we need I context binds. So we can take the binds from the match. So let me just rot for stack st match dot binds. So this is going to be context stack expers binds. Then I'm probably gonna do rot prime context binds, and then like pop and 0 I context rot for prime and just call it. I think that should do it. That should finish type checking. Hopefully. But yeah, this is just the type checking, so assembly is not done yet. We'll see how assembly works though, because yeah. Okay, let's see what happened. If we run type checker, it's all good. And if we go to 08, if we add this OK at the end, it should say that it's not defined. Perfect. So we are actually type checking the match statement properly. We just have to implement the assembly that actually makes it like work, right? So what I'm probably gonna do is not even sure, because we have to pop those items from the stack, but somehow keep them in the context. So let's say we allocate some variables locally, we store the items from the stack in those variables, and when we use these things, we actually say that instead of calling a function, we just take them from the variables, right? That's how I'm planning to do it. So if we go to the main function, let me just find some assembly that does that. So this is condition, this is expression. So I'm looking for emit expression name, right? Here we do a function call every time, right? We just do a function call. So we'll have to see a way. So I'm pretty sure the stack assembler has the context stack. It doesn't. Yuck. But it doesn't even matter though. So yeah, we'll have to see. Maybe we'll add some kind of context in the assembler as well. And when we hit a match, we insert those symbols into the assembler context. And when we get to this point, we say, okay, let's emit like a name, right? So if we have basically, let's just say here, like some to-dos, add a context in Asm in the assembler to know when we have locals, basically like binds. If it is a bind, then we take it from a variable. If it is a function, we just call it. So that's basically the idea, right? If we hit a match somewhere in here, we have to add those binds into the stack assembler, into some list. We'll have to add a new list in there, and then here we look through that list. If we find an item there, then it means it's a variable, so we take it from a variable, and if it's function, we take it from a function. So yeah, that's kind of the plan. So yeah, I guess, I don't know, next time maybe we'll do it together, or I'm gonna do it alone and just show you the results. But hopefully next time we'll have the match statement working. So yeah, right now we just have the type checker, so we can just assume that this code is correct, right? We just have to actually implement the assembly for it, because right now if we try to run the assembler, it's gonna hit to do, and that to do is like here, right? Because we don't handle the case when it's a match. So we have to handle that case, generate some variables, and then also do some changes here in expression name. And then it's gonna make things so much easier, the match statement, hopefully. Like maybe we can even rewrite some of the parts of the compiler with matches. And I guess the next step after that is the while loops. So if you don't already know, I have this I just, writing ideas in the examples. That's how I think the whiles should look like the label where you jump, condition, and then the body, and pull jumps back to while, and then this is the condition, and this is the split between condition and body. So yeah, but that's kind of all for today. All right, we managed to add matches from the Lexer stage up until the type check, and we are left only with the assembler. I have kind of an idea of how to do it, so it shouldn't be that problematic. And yeah, we'll see the next time. So see you. Right, so let's actually continue with the where we left off last time. So we implemented the match statement, and that's working like up until the type checker stage. So we are able to parse the new instruction, but we want to also generate the assembly because we want to actually use it. So let's do that in this new session. So what do we have to do? Since match is an expression, we have to go to this emit expression part, right? And we will need to add another case when we encounter match. And when we encounter match, we convert it to a match statement, and we are gonna emit a match expression, right? Let's not forget about another p here, and that's how we are gonna add our new match, right? So I guess we can just copy paste this if this condition function just to have some starting point, and we are gonna have here a match, right? So thing is that as I said, my plan is to, like, for each variable from the match, my plan is to pop from the stack. So for that we have a stack pop function predefined, right? This function returns the result in arrax, so we'll get the result in arrax, and we'll have to move this arrax value somewhere on RSP minus some stuff. So we have to allocate some local variables. Now I'm curious if we'll be able to do that easily in the middle of execution. So probably yeah, because RSP is just RSP, we shouldn't really care. Right, so like we increase the execution. So if you think about it, the program has an execution stack, and we manage our own stack, right? So we don't use the execution stack to store our stuff. We allocated some memory for the stack in the beginning, so we can use RSP and RBP however we want, right? We are not limited by that, which I think is pretty nice. So what should we do next is store those variables that we popped from the stack at the local variable location, all right? And each time we find those variables, we have to replace them with this variable from assembly. So knowing that, let's try to do that. So first step, I guess, is well, so I have also to do here on how we are gonna use the binds, right? I'm just thinking that, so how does stack assembler function name work? Because I don't remember when I implemented this thing. Okay, so it searches through an array, so through the func map. Okay, so searches through func map, but we won't use func map. That's obvious. So let's go to the like where we left off. So here. So first things first, we need to allocate some memory, right? And I mean, I really like to do v-splits, but in this case it's kind of hard. I mean, let's just remember where we left, and we can see, for instance, in syscall3, we do something like that. We pop from the stack, and then we store the variable in rbp minus something. So what we have to do is to simulate this part. Right, we have to simulate this push rbp, move rbp rsp. We kind of simulate like entering a function somehow. So yeah, that's the idea. So we are gonna do this part, and I mean, if you remember from the cool compiler, we were doing the same thing for the let statements. So I guess match is kind of similar to that in this regard. So save the return address. I mean, you know, it's just rbp setup stack frame with rsp, and now we have to allocate some variables. And how much are we gonna allocate? Well, it depends on some stuff. Okay, so here let's swap. So we have the match and the assembler, right? So because of that, we can easily just call to emit. Right, so at this point, we'll have the match, assembler, string. So we are kind of cooked. Then I'm gonna do something else. Let's do a swap. So we have assembler and match. We are gonna duplicate the match so we don't lose it. So here it's match, and what else I'm gonna do is stack st match dot binds. So I take the binds, which is an array, and I also am interested in the length of that array, right? So this L, well, let's keep it like this, array.count. This L represents how many variables we are gonna allocate. But since our stack is like 8 bytes long and our addresses are 8 bytes, we have to multiply it by 8. Right, so this is the amount that we have to subtract from RSP to allocate these many variables. Okay, makes sense, makes sense. So let's int show that thing, right? Then let's put this guy right here. Let's swap and string concat. So if we concat like this, we are gonna get subtract from RSP some stuff. So we are gonna have match and the string. So what we need to do is rotate dup rot. So if this construct with rot dup rot, or I guess swap dup rot or something, what it does is it brings this forward, duplicates it, and then takes whatever was first, it puts it back first, right? So it's gonna look like match asm s. So we can just call emit afterwards, and these things are gone, right? So we just printed the beginning of the match, right? We also have though to do the end, so let's just do that. Basically the end, we have to add the binds. So what we are gonna do is again swap. Pretty much we have to do the same thing, but instead of sub, it's gonna be add, right? Makes sense. We deallocate the variables. And finally, we restore the return address, which, I mean, it's not necessarily return address in this case. RBP is just RBP. It's just another register. It doesn't have any special meaning in this context. So let's see what we are gonna do now inside of this match block. Right, let's see what we are gonna do inside of this match block. So I can delete all of these. Pop2. Why not? So for each of these variables, we need to call to stack pop and save them in their like corresponding local variables. That's a bit difficult. I'm curious what log0 was. Log0 is 8. That's interesting. I'm kind of pointing. Oh, anyway, let's think about it, right? So if you're the first variable, it's gonna be RBP minus 8. RBP minus 16 is the second one, and so on and so forth. So what we have to do here is copy this function, and let's just say we are gonna get an index I here, and we are just gonna no, but you know where this thing is gonna suck, although I'm not sure. Oh fuck yeah, if you have matches in matches, it's gonna be kind of bad. So no, in a weird way, I'm kind of curious. I still have the cool compiler, obviously. When I did the assembler, well, I think in here in cool, we also had another approach because we used some kind of RSP minus. So here we were doing some arguments, but this is the function call because we were using tree address code. If you're interested, that's a pretty cool concept. Assign new. So we were doing like assign, but we don't have a let. Anyway, like doesn't matter. So I'd say we are kind of cooked because we have to push this RBP. So pushing this RBP offsets the stack by 8. So if we are trying to access, so if we have a match inside of a match, I kind of don't want, like, what if I don't care about pushing RBP here, right? Because RBP is saved anyways. So if we just destroy it, it is what it is. And what you have to not forget here is that now, since we don't offset by 8 anymore, we start at 0. So we change that, right? But I think it's gonna still work because we already do this pop RBP and push RBP in the function calls. So we don't have to do them as well here in the middle of the function body. I mean, usually you would allocate all the variables at the beginning of a function just to avoid that, right? But since we are just trying to make it work, we are just gonna make it work. Okay, so here it's an integer, right? So what are we gonna do here? Well, you know the drill. I'm just gonna use pick because I'm a lazy mofo. So let's do pick int pointer. Now that we have pick, life is so much easier. Stack is the match pointer. Yeah, honestly, I was like asking ChatGPT to do some weird stuff, and it kept saying like, use pick, use, like, inventing it, right? And I was telling it, no, you dumbass, don't use that. I don't have that function. Use dupe and swap, and it wouldn't listen. So I was like, you know what? ChatGPT kind of has a point. It's much easier to have pick, but like, honestly, it's kind of cheating if I think about it, but it is what it is. I consider it a bit cheating because you can access any point of the stack. So it's like, it's more of an array language now that you have pick. But match, I feel like it's more of a nicer way to do it, because I don't see it as cheating, because it's type checked, first of all, right? So you cannot go like here, I can just say 20, right? So it's whatever, but the match is type checked, so that's why I see it more as it's fine to use it. So yeah, okay, so here we are inside of the for loop, otherwise we are outside, so we can just pop 3 and get out. So I'm just gonna take this thing and let's put it here. So as I said, we need to call to stack pop, which is a predefined function in our thingy, and we have to move that thing into 0 plus 8 times I, or I guess it's straight up I times 8. Okay, so how are we gonna do that? Well, first of all, to be able to do these things, we need to swap match awesome, right? And here we need to swap again well, we don't even need to swap, we just need I, we need a value of I. So let's just do pick int pointer. Then using pick is like, sometimes I forget I have it, but sometimes, damn, it's so convenient. Let's multiply it with 8. or you know what, we can do like shift by 3. That's something we can do, why not? But I'm just gonna keep it on multiplication because it's more obvious, I guess. Or you know, maybe for someone it's more obvious to do shift, but I don't know. Anyway, let's int show this value, and then we have to copy paste this entire thing, move it here, put that, let's swap string on cat, and then we need this part, here. Oh shit, did what? And let's string concat. Okay, so this gives us match awesome string, and as I said here, we can just do something like swap dup rot, right? And again, it's gonna give us match awesome string, and then we can just call to emit. So what comes next now? Well, next we should swap, so we have the same format, because we want to call this thing, oh shit, so this is match, and these are like binds, right? So we have to recursively call to this function. And important thing is, let's not forget about incrementing by 1. Prime and I plus 1 as a match. So yeah, this should generate all the binds. Okay, so let's see. Okay, so it's match awesome match. So I have to do something like let's dup to swap 0 rot prime. So it's like we copy both of them, but the second like pair of values, we swap them around, and then we put a 0 at the beginning, so it matches the inputs for bind. And this thing is gonna return, I mean, it's not really gonna return anything, but it's gonna leave the stack with these values, match and awesome. So that's how we are gonna emit this thing, right? So we can see like it's not done yet because we have to do emit expressions as well, but we can just run make, and I mean we can take a nap until it's done. I'm really curious if we'll be able, like, honestly, when I managed to, because it, like, I was, Jesus Christ, did I have a stroke? Anyway, so when I just finished the type checker, I was like, there's no way it works. And yeah, it didn't work, obviously, first try. But I did like really small changes, and it worked like instantly. Just running make, it compiled itself, right? So I was like, holy shit, it just worked. But it was a bit tragic with the memory usage. So the main driver for the memory usage are the arrays, right? So because we use a lot of arrays, and if you look here, where the fuck is the array? We have 32, like an array by default has a size of 32, and here I had 1024. Imagine the memory usage then. And yeah, I just changed it to be smaller, but yeah. Anyway, so where is the match? Where is the main? So that's the call to main, and here is the main function. Okay, I have no idea what am I looking at. I compiled the right thing, right? The fuck? What? I'm not sure what it is doing. Because it doesn't look like I compiled the right thing. But I did. Huh. You know what? Let's go to empty. And let's do here a match. So let's have like 0, 1, and let's match A and B. In and let's say like A. So this is something really easy, right? Let's go with, oh shit, examples. Oh my god, empty, right? So okay, now it looks better, right? So we have the variables, the literals, right? And here you can see that we make this thing, we subtract from RSP. So we move into RBP, we move RSP. Into RBP we move RSP. Nice. Then we subtract from RSP 16 because we have two bindings. Then we call once to pop, and we move into the first variable, we move RAX. Then here we pop again, and we move the second variable into RAX. And at the end we destroy the local variables. I think that's pretty good. I think that's pretty good. But you know, like my concern was something like, what if you do AB and then match, right? And do like A. Okay, so let's say you do XA, right? So you shadow a variable, and this shouldn't be allowed. So if I try to type check, it's gonna say A is already defined, right? Which is nice. But if I call it like Y, it shouldn't fail. But you can see now the problem. I mean, I have to implement it. So yeah, let's do it. Let's keep it like this because it's gonna. Actually, let's have it like this, and we are gonna test both of them. But at this point, we have to emit the expressions. We have to emit the expressions. So how are we gonna do that? Well, there is something really easy to do, is to just call to this. Just call to emit expressions, and emit expressions takes the assembler and an array of expressions. So imagine we do something like dup2 swap. So we have like something else, assembler and match. Like in this case would be nice to use match. Imagine that. Using a match to implement match would be like boom, crazy. So stack ast, like we are getting into inception territory, right? So imagine we do this thing. What do you think is gonna happen? Like, sure, it's gonna be close, right? It should be kind of close to working, but we miss a small thing. It's a small thing, and you'll see what in a second. I mean, it really is anticlimactic how long it takes sometimes to compile. Like sometimes it's faster, but anyway, so you can see here that it allocates the variables, and then you can see the issue. It tries to call to a function, right? But as I said, we don't want that. We just want to read the variable and I guess push it on the stack. So what do we want in fact is to read this thing, put it into RDI, and call to stack push. Right. But why does this happen? Well, if we scroll a bit up, already have what to do here. And I said that when we try to emit an expression name, so expression name is emitted here, we just say that, okay, it's a name, so let's just call the function, right? So it's a function call. We don't care about it. But I think I want to have a context inside of the assembler with the current variables, because a is a variable, it's not a function, right? So we need a context, a list of things that we can have here. And the other problem that maybe you can see if we add the match back is, maybe it's not that visible. Let me see if I can spot it. So here RSP decreases by 16 again, right? So RBP is now, it's now lower. So if you think about it, how are we gonna access the variables? So I think we don't even need to move RBP, RSP. I think we are not supposed to do that. Only issue is, oh, but no, it's not an issue because normal functions don't use the stack, so it's not going to be an issue. So we can keep RBP the original value, right? So I guess in here I was wrong when I said this with move RBP RSP. We don't need to do that, right? Because RBP is already set here and we don't change it, so it's fine, right? And we are not gonna do this stuff. And what's gonna be interesting here, we shouldn't say -0, we should say -16 because it's the third variable. So if we take a look here, x is the third variable because a is the first one, b is the second one, x is the third variable, right? So it should be 16 here, and here it should be 24, but we'll see how we can do that. So yeah, like we have to also see how we can do that, like have nested matches. But I think removing the RBP is the first step. Right, so it might be that here we have to do something more than just I multiplied with 8. We might have to look at the context that's inside of the stack assembler. So let's go to data stack assembler, and let's add another array maybe it's going to be the first one just so we get errors more quickly. Bind map, right? So it's going to be the binds, and I'm gonna create an array here, string size of create an array. So we are gonna have a bind map where we are gonna store our bindings in the stack assembler. Okay, first it's empty, all right, and let's try to fix this this problem. So when we emit the match binds, for instance here, what do we have to do? I'm pretty sure we have to pick the assembler, stack assembler I match I assembler I assembler stack assembler dot bind map array dot count and plus. So we'll have a match assembler I plus the number of bindings that were that are already existing. I don't know, let's call it C or capital B. So now we are gonna multiply that thing with 8. This won't really change anything right now, right? But what do we have to do is actually take the binding. So for instance, oh, we don't even look at the binding. I thought we do look at it. Yeah, we do here, but whatever. So let's do it here. So we are gonna pick the match. So stack asm ast match I match asm match stack ast match binds match asm binds, and then we can pick the integer I match asm binds I. We can array.get unwrap. It's a string, right? If I remember correctly, the binds, I already forgot. Data stack ast match. The binds are nodes. Okay, so it's a node. Stack ast node dereference, and then stack ast node value. So we get the bind, right, with a name, right? It's the name of the bind. Stack assembler. Do you have like any sort of functions? I don't think so. I just want to add the binding to the func map. I'm sorry, to bind map. I'm pretty sure we have something like assembler func name. So I want to implement the same thing, but for binds. So it's gonna be stack assembler bind name So it should be, we give it assembler and the string, like the name of the bind. Here we should get the bind map, right? And we should recursively call to this thing. And I think we just want the integer. We just want its index for this bind name. So it gives us the index. It's pretty simple. And you know, if it's not there, it gives us a new index, so it's fine. So by name, it goes through the array. Oh, it's just func name, but right, isn't it? I think it's just func name. Yeah, I think it is. I think it's the same thing. You can just reuse it, probably. Can just reuse that function. It's like gonna add the string into the bind map and give us the new index if it's not there. So yeah, this function is kind of useful when we are gonna do the search. So stack assembler string. Okay. Stack assembler bind name. But this is just like adding it. How are we gonna do like a differentiate between the two? I mean, it's kind of meh because I just want a way to append to bind map, not necessarily add bind, right? So it's gonna be bind append. So we just take this and we don't even return anything. Okay, and then I do something like swap string and array dot append unwrap. So yeah, it's just appending the bind because that's what we need. So yeah, so here I can one pick stack assembler pointer. So let's show what we have. Match awesome, bind awesome. So then we swap and append. So we have I match awesome. So at least what are we gonna see now is that oh shit, yeah, here we don't even need to do I plus, it's just B times actually. Shit, right, it's just B times 8. Because now it's gonna be like 16 instead of 8. So I should do just so here we picked I, we should just pick, actually we should just dupe. So we have I match awesome awesome, then we take the count, so we have B, and here we do B times 8, right, the number of binds, and then we append the bind. So if we go here and we add all of those matches, we run make again, we are gonna get the result that we expect. Right, only thing is that we need to pop the binds once we are done. So we have to do the same thing here, but kind of in reverse. Oh my god, 19%. Right, so now you can see it's 0, 8, 16, 24 as it should be. We still have to fix those names. But yeah, as I said, we have to remove the binds when we are at the end. So let's binds like pop or something. So we can just copy paste this thing. Binds pop. So we do the same stuff. Okay. But here instead of like binds append or whatever, we need to bind pop. Pretty sure I want to dupe so we get the same result. Oh, then we swap rot whatever. So yeah, we just do something like this. We don't even need a match, but whatever. So now bind pop. If we search for bind append, let's do bind pop. So we just get the array and then array dot pop unwrap. All right, so this is gonna do a pop for all the binds that we added, and that's what we are supposed to do at the end. So in case you are wondering, let's say we had another match statement right here. I mean, I can do a pop here just to get rid of x. So this way a and b are gonna be new variables, right? Let's see that. Let's see that in action. And all the usages should be safe, because if this passes type check, then it means it's safe, right? Oh shit. So it's 0, 8, 16, 24. But then why does it look like that? The fuck? So it's like 0, 1, then it is like A, B, then there is another match with X inside, it adds 16 here, then it's a stack pop. Another stack pop. I don't know where these come from, but then we have like 0. What the fuck? It looks really weird, because we have the 0 and the 1, that's these ones, then we have subtract 16 for the match, then stack pop and first variable, stack pop second variable, then we have the A and B from here, then we subtract 16 more for the second match, stack pop third variable, stack pop fourth variable, X, we close the inner match. Alright, and then it's a stack pop. Why? Why is there this stack pop? Fuck. Oh, because I recursively called the wrong the wrong function. I was like, what the hell? And it was just adding them back, so yeah. But now we should see that the second match starts with 0 and 8. That's the point of doing this. So let's see if that happens. See if that happens. Come on. Damn. Okay, and yeah, you can see it's 0 and 8. Nice. So matches work as they should. Okay, but still we do this weird call instead of using the right thing. So what can we do then? Well, we call to emit expressions, right? And this one goes through here, and it calls to emit expressions prime, and each time it calls to emit a single expression. Then when we find the name, which is either a variable or function call, we call to expression name, and the expression name should be here. So what should we do is first we check if it's a variable, if it's a bind, and if it's a function call. So how can we do that? Well, with a function, obviously. So let's say we have a function stack assembler bind has, maybe stack assembler string boolean. So this will check if we have, so I might need this one. This will check if we have the name in the bindings, right? So we take the thing and we have to do stack assembler bind has prime, maybe with a 0 rot prime, and this should return a boolean. So function bind has prime, it's an integer, it's an array, and it should return boolean. Array name, right? So if we're gonna do a swap iname array, then duplicate count, we get the length, then rot for dup rot, we get this stuff, and if it's too big, we have to do like pop3 false, right? It's not in the bindings. Otherwise we have to dup2 array get unwrap, so we get a pointer which is a string, we do something like this, like rot4, bring the name forward, duplicate the name, switch it around, string equals, so we are left with this. And if we find that the name is inside of the array, we should pop3 true, because we found it. Otherwise it's a good idea to do something like rot prime here though. So we have i+1 array name, and we just call to bind as. He's gonna return a boolean. Okay, so this looks good. So now we have bind has. So in here with the to do, what are we supposed to do? Well, I think I'm gonna dup2, so we get some stuff, assembler name, and we can do stack stnode.value. So we get assembler and the string name, oh my god, name, and we can do stack assembler bind has, or function bind. It's just bind has. Yeah, and basically bind has takes the assembler and the string. So if we come here, we replace this thing, is gonna give us assembler name and okay if it exists. So if it has the thing, let's do to do pop2, else we just do the usual. So it looks like this thing should return an assembler. Right, whatever, it returns an assembler. So what we need to do now that we have a binding is just have a similar function to this. So it's gonna be something like function stack assembler emit push bind. So we need to take the binding and push it. So let me just do a to do pop or something, and whoopsie doopsie, do stack stnode value, then call to that swap pop, give us assembly string, swap to rot emit assembly. So we are left with the assembler. Let's see if it compiles. So yeah, we should just print. So what we need to print now, that's a good point. Well, we need to do something like move into RDI, and we need to do the reverse from RBP minus, and here we'll use I times 8, where I is the index inside of the bind map. And then we just need to call to push stack push. Oh, I mean call stack push. I think that's good. Okay, so we cooked something wrong. Line 3239. 3239. So here we have to swap first, I guess. Swap first. And they also want another function, same as has, but it's gonna be called index, and it's gonna give us int. So why do we need two functions? Because why not? So for instance, if it's too big, we are just gonna say something like -1. Can say that. If it's not, we are just gonna swap rot prime pop2, and otherwise we do that. I mean, I could have just used this thing, assembler bind index, and if it's less than 0, it's like has. So this is index. So basically has can be just index is less than 0. So here if we do index dup, we are gonna have asm name I, right? And now it's like if it's less than 0, now if it's greater or equal to 0, we are fine, but if it's -1, we are not, right? So that's the idea. If it's greater than 0, we are push bind, otherwise we are function call. And what's the deal here? We are gonna get an I. So here I have to pop the I, so we are left with asm name. Here I'm just gonna rot prime it. Shit, I don't even know. Let's just dup3 swap, right? So after this part we are gonna have same stuff, but asm I name. So what if here we get also the integer or the index? So it's just easier for us, right? So that thing is gonna give us the entire thing. Or what if it just emits the stuff, so we don't even have to worry about it? So in the end, we don't have to pop anything. This thing is just gonna give us name and I, so we can just pop 2 and be left with assembler. So that's what I'm thinking. This thing should just give us pop 3. Okay, whatever you say. Let's see if the error still appears. I'm just gonna look. Push bind 3343. Whatever. Now it's gonna work. Pretty sure. And I mean, the memory increases. That's always a good sign. Ah, shit. Wait, what? 3237. How did I write that? Okay, so it should be int. For some reason I just wrote index. Doesn't make sense. Anyway, so let's see here. How can we do that really quickly? This looks so weird, but let's just take this part. I mean, I'm just gonna take everything because it's funny. It's the reverse of this thing, which is quite nice. I don't know where I was left. It was somewhere here. Nice. So now if we run the thing, we should get a to-do at 358. We should get a to-do here, but stuff's broken. What can you do? Stack push. That's nice. So let's see how we can fix this. So on the stack we have asm I name, right? So what if we do the following? Swap 8 multiplied, so we get asm name I times 8. Nice. Then we need kind of this, so we show it, we move rbp minus whatever, concat, so we get, actually what do we get is asm name s. So we have to rot, dup rot, so we have name asm s, so we can just emit. I don't need that. We can call to push and we can pop 2. Nice. I think that's it though. So let's try to remake it. And I think match should actually be implemented. You know, I just need to write unit tests for it and make sure that it actually works. But I have a feeling that this is everything we need for the match. Pretty nice. That's really cool. Because yeah, like match is like so needed. Would have been really awesome to have it before though, but let's see. So let's take a look right here. So we take from the third variable and we push it. Do we take the third? Yeah, that's nice, right? I think that's pretty nice. So what do you think will happen if we compile this thing to an executable? Let me just give you a hint. Yeah, it's gonna print the 69. That's awesome. Let me just 0. Really, man? Empty.o. No, like let's make this tag longer. Let's make it be more awaited by using make examples. Make examples just builds all the examples, so we'll see if it's actually working or if it's just sometimes it feels like watching a water boil when you look at how it compiles. Oh, it's a bit slower. Yeah, whatever, the while loop doesn't work, so okay. So what if we run 0 empty? What's the status? Shit. Well, completely unexpected. What if we do a oh my god, I kind of need I need this and this and the LD, so it's all of this stuff. Oh, okay. Oh my god, it really wants me to. Okay, whatever. No way. If I knew, I would just press Ctrl W, but okay, dude. So let's recompile. And let's see what status we get. Oh, it's like just printed 48. Yeah, I really have no idea why. So you can see that we put the literal in RDI, we push the address the same, subtract from RSP 16. Then we stack pop. Could it have something to do with RSP? being changed. I mean, I don't know, because if you think about it, if you enter another function, it's gonna push RBP and it's gonna set RBP to the value of RSP. So it's not gonna influence that. So here we just move this into here. Stack pop, we move this into here. Call stack push. Yeah, like what? I can try to GDB, because why not? Break on start. Let's run. Let's next instruction a couple of times until we actually get to the beginning. I think this is the beginning. Don't quote me on that. So this looks like 69 and then 1, right? And this one is it looks a bit weird though. If I could maybe look at 0 Jesus at 00 assembly. Am I blind? Strange how it's the fuck. I don't know how it got mixed like that, but I mean it's still not working, right? So it's pointless. Out dot 00 empty, and it comes from 00 empty dot o. I don't know how it got and what if we see the status? It's 48. Like, it's weird. Let's start over. Let's break on start. Let's run. Next instruction until we get to the call. And here we see move obs. So it's this into the literals. Then we push the other one. Then we subtract 16. Then we call stack pop. So in RDI we should see 1. Yeah. Then we put that whatever into the RBP plus 0. Then we stack pop again, so we should see the 69 in RDI. The fuck, we don't see that. Oh, but you know what? Here I said I have to do something else, but yeah, whatever. But I don't see... Oh, it's RAX, I'm sorry, yeah, it's fine, it's E. But here I did something wrong. Okay, so in stack.stack, I was too excited. Right, we should do RDI, guess the value from that. So if I run make again, right, we have to read the value from the variables and push it, not write it. So that was the problem. Anyway, so now it should work. Now it should work indeed. So let's see. Once it compiles, we should see it working. And just want to say, ladies and gentlemen, we have match in the language, so much easier memory management. Anyway, whatever. Let's compile it, and if we check echo status, it's a 1. Interesting. I mean, it is a 1, right? I was down. 0, 0 empty. Huh. Oh, I mean, I take them in the reverse, so here it depends, right? Do we take them? I mean, yeah, we should take them in the reverse order. Whoa. Stack. So when we push bind, not necessarily when we push bind, but that also works. But it should be easier when we insert the binds. So here when we generate these guys, match binds, we should probably do L minus I. L minus I minus 1 or something. So here we see we take B. I mean, it's a bit of math, but you know, I guess it should be B plus L minus I in here. We can do that, no problem, because we can easily just do like pick2 stack st match I match asm B match, and then stack st match binds array.count, and I said we add L to this thing, so it's I match asm B plus L, and we have to subtract 1 now, so we do 0, 1, 2, 3. I match asm B plus L I. So we do, I think I want to do, so let's think about it. If it's index 0, we have to add L minus 1. So let's do a minus. I match asm B plus L minus I. I'm pretty sure we have to do minus 1 as well. And I'm also pretty sure we did this stuff before for something else. I guess function arguments or something like that. But maybe it looked different, but it's the same idea, right? We want to take the because here in 0, 0 empty we pop them from the right to the left, but we want to interpret them from left to right, just to, because we are, you know, we are used to reading from left to right, and that's, I mean, even for people that read from right to left, they would read from here to here, right? So it would be the same stuff. Anyway, you get the point. Oh shit. Stack st match star. we dereference it because it's a pointer. And this should maybe make stuff much easier for instead of using pick, we are gonna use match. That's nice. And I think I'm also gonna add while loops and then do a refactoring of the compiler because that's gonna be so helpful. So now if we check the status, I mean, we were close, but so what happened now? Fuck. It's not minus I. Okay, it's funny. Oh my god, again? Did I just get vimmed? So if you think about it, it's 8 and then 8, but it's because I do plus L. The problem is that B increases, right? B increases. So that's the issue, that B increases each time. So how can we do this then? So the second time B is gonna be B plus 1. I don't want to say that we have to do 2 times I because that's stupid. But I think that's what we have to do if you think about it. But so it's B that increases by 1. Damn, the math is not mathing, to be honest. So B is the size of the array, and we want to say that so if we decrease by I, we get the original size. Of the array, right? So if we do 2 times I, like it just makes sense to do 2 times. I know it's dumb, but it is what it is, right? Because if we subtract I twice from this thing, we first of all get the original size. So maybe it's more obvious if I do it the other way. So it's B minus I plus L minus I, right? Maybe it's more obvious like this. And yeah, the reason is that B and I, both of them increase by 1 at each iteration. So you have to we need the original B basically. So yeah, the fuck, it was faster. So we get 69. I mean, yeah, that's kind of it, right? We just needed these to be in the reverse order. And would you think about this? Would this work? It does work. Would you look at that? And you can see here that here it pushes them in the reverse order, here in the reverse order as well. So that's nice, right? That's pretty nice. So yeah, I mean, it's so cool, dude. Like finally we have a nice something that's gonna help us quite a lot with this language. Like while loops, I'd say they are not that big of a deal as the pattern matching is, because I mean, you can see it how difficult I have to invent this ugly ass function just to be able to simulate that. And like the difference between match and peak is that peak is not type safe and match should be type safe, right? So here the compiler knows that a and b are integers, so I can do stuff like ab plus, and it's gonna know that this thing is 70. And if I put here a string, it's gonna tell me, yo, dumbass, plus has non-matching arguments. Like, this is so cool. Yeah, so I mean, enough being a dumbass, and let's just push the changes. So yeah, like, I'm gonna do a better match example, but yeah, that's basically it for today, right? So we were able to implement the match keyword, which lets us pattern match the stack, and it consumes the stack, and then it gives us variables that we can use, similar to functions, but they are just variables, right? So inside of assembly code, they are gonna look like, if I can get the assembly, whoa, I mean, it is what it is. It was in the assembly, but now it's gone. So yeah, I have to add a keyword, but yeah, this is the part, right? They are just variables, they are not function calls, so there's the difference. But thank you for watching, and yeah, let's see next time when we are gonna do maybe something more, or maybe the next time will be just starting on Advent of Code, maybe. Like, we have to do at least one day with the stack, like, that's for sure. So now tune in for the next time when hopefully it's gonna be Advent of Code in stack, or we'll see. So yeah, see you in the next one.